Alright, so here we could have a base case of 1 because 1 is an odd positive value of n. So base case of 1, you'll see 1 cubed minus 1, that's just 0. And that is divisible by 24. Yeah. So then we would look at our assumptive case. So our P of... Now, we want, in this case, if you just do k, it's going to be harder than making it in the odd form. So what we can do is say, let's choose a k that makes it nice and odd. So 2k minus 1 is in that odd form. It's for some integer k. So if we assume this one's true and then go to the next odd integer, which would be 2k plus 1, and prove that's true, then that's okay by induction. So let's assume that P of 2k minus 1 is true. So that means that for this some odd integer, 2k minus 1, where k is an integer, greater or equal to 1, we would have, what would we have? We'd have 2k minus 1 cubed minus 2k minus 1 would be equal to some 24, let's say p, for some integral p. And then actually we might, and then we'll be trying to prove that 2k plus 1 cubed minus 2k plus 1 is equal to 24q for some integer q. Alright, so what we might though want to do is just expand this out. I'm going to have to do it down here. So 2k cubed, so just do some algebra, but maybe you want to start with factorizing by 2k minus 1. It makes it a little bit easier to then expand that out. So we've got our 2k minus 1, and here we've got our 4k squared minus a 4k plus 1 minus 1. So you'd get that. So 4k squared times 2k, so we've got an 8k cubed. We're going to get a negative 4k squared and a negative 8k squared, so that's negative 12k squared. And then we're going to get a positive 4k. Alright, so just knowing that that one, 8k cubed minus 12k squared plus 4k is equal to 24p. Just having that handy, then when we look at our left-hand side of this case, so again, maybe I think an expansion would be required here, so I'll just do a squared expansion, makes it easier for me. So I've got a 2k plus 1 here, I've got a 4k squared, I've got a 4k, and I've got a plus 1 minus 1. So again, it looks very similar here. 8k cubed, 8k squared, 12k squared if I add the 4k squared, and a 4k. Alright, but what, I want to use this, so I'm going to force it to be that. So it's 8k cubed minus a 12k squared plus a 4k. So you can see, to balance it, I'm going to have to add a 24k squared. So this is all from our assumption, from our P of 2k minus 1, we can say that is 24p's. And then we've got 24k squared left over. So you can see we can factorize by 24 to show that it's factorizable by 24, or divisible by 24. So we've got like 24q, because p and k are both integers, so that would work out fine. So that equals our right hand side. So therefore our P of, in this case, 2k minus 1 implies our P of 2k plus 1. So just note that little difference. So that is implying our next odd one, which is 2k plus 1. So when we assume this is true, this one is true. Therefore, it's true for all odd positive integers values of n.